Welcome back. In this video, I want to focus on more, I don't know how to have to say this, is basic or advanced. Well, another aspect of things that you need to think about when you're writing. So layout, so basic formatting. What things do you need to think about and do for formatting scientific articles, laboratory reports, and so on. Proofreading, I keep slipping in mentions about proofreading in some of the other videos because it's really important. But I want to talk more about proofreading here and at the same time provide a few tips, things for you to think about in order to improve your writing, make things better for you and for your reader. So some of the stuff that I'll say in today's video, I've said in some of the other videos, but it's the type of thing that it's really important. So I really want to repeat it, and I want you to think about it and use it to improve your writing. Number one, possibly one of the biggest problems I see in student laboratory reports. You should write your reports for a naive reader. What is a naive reader? A naive reader is someone who doesn't know what's in the report, okay? So some students think, oh, I'm writing this for my professor, they're going to read it, they're going to give me the grade. Well, that is true in most cases, but that's not how you write the report. The report is supposed to be written for a naive reader, not for your professor. So when you're writing a laboratory report, you should imagine a few things, picture in your minds possible readers. So imagine a reader that has never taken the course. If you're writing something for a course, imagine that the reader has not taken the course. They have no experience with the course. And that means, or probably means, they have no knowledge whatsoever of the experiment you did or the research you conducted. Nothing. They do not know anything about what you did or why you did it. If you are, for example, a freshman in college, a first-year student in college, then imagine that your reader is also a first-year college student. But imagine that they are not studying in the same major you are, and that they're not studying in the area that the research involved. So if the research involved physics, maybe they're studying psychology, okay? So think that they do not have a strong background in the area of the research or the experiment. They're in a different major than you. They've never taken the class. They are not in the class. So they are naive. They do not know about the stuff you will be writing about. Consequently, as you write your report, you must explain everything very clearly for this person who does not know. They do not know the background. They do not know what you did. They do not know why you did it. And of course, they do not know what you found. And even if you told them what you found, they might not know what does it mean. So you're writing for a naive reader. Okay, so explain everything. Give them the background. And as part of the introduction of your report, provide them with the goal. What were you trying to accomplish? And oftentimes that would be a hypothesis. Also give them what you did. So how did you conduct the research? That would be your materials and methods section. So make sure that they know precisely what you did. Also make sure they know what you found. What are your key results? They probably do not want to know every single measurement you made, but they'll probably want to know the big stuff. So what were the main things? What were the key results? Maybe some of that will be, or the main ones will of course be in sentence and paragraph form, but maybe supplemented with a figure. So that's the results section. And what are your conclusions? What are the implications of your findings? This, of course, is your discussion section. So as you're writing your report, always remember you're writing it for someone who does not know what you did, who does not have the background that you have, that does not know why you did it, and of course does not know what you found, and even if you told them, they might not know what that means. All that needs to be in your report. So as you design your reports, think very carefully about writing for the naive reader. That is critical to writing a good scientific report, and certainly for writing a good laboratory report for a class. Now, what about formatting? Just general formatting. Depending on if it's for a class, your instructor might give you specific instructions. Obviously, if they give you specific instructions, do what they said rather than what I'm telling you, okay? If you are a scientist and you're trying to publish in a journal, they almost always provide detailed instructions. For some journals, they'll tell you to consult a particular book, a manual. And I have one of these that's 439 pages long of instructions of how to format the documents that you send them. I'm serious, I'm not joking. 439 pages long. It has everything in it, or it seems to have everything in it. Anything you could imagine you have a question about for formatting, it's in this book. Now, if you're given instructions, follow the instructions. But if you're not, what should you do? Well, in general, you'll want to use an A4 paper size. So unless you're told otherwise, my suggestion is use A4 paper size. So in your word processor, make sure it's set for A4. One big exception, if you happen to be studying in the United States, so you're doing some study abroad or something, use letter size. In the United States, they use letter size. Most of the rest of the world uses A4. There are some countries that use both or that use something different. So check to see what is regionally appropriate. You'll probably know, but if you're in Japan, go for A4, unless your professor tells you otherwise. What about the margins? So the empty space around the edges of the paper. The empty margins should usually be, unless you're told otherwise, 2.54 centimeters. Now, you may think 2.5, why 2.54? Well, again, this goes back to the imperial measurement system that preceded metric, and this is equal to exactly 1 inch. So 1 inch margins sort of became the standard, and even in countries that are fully metric, they still use the same amounts of size for the margins. So 2.54 centimeters is the standard. Obviously, if you use 2.5, probably nobody would care. Nobody would probably notice, but occasionally somebody's really picky. The university where I received my PhD, when you bring in your doctoral thesis to the office for submission, they actually measure the margins and lots of other stuff. They literally take out a ruler and they measure the margins. And if you're off by anything that they could measure, they send you away and say, fix it, and then come back, make an appointment. So some people are very picky about this stuff, but 2.5 is probably fine for most things. 2.54 is technically is the standard. What about fonts? I've mentioned this before. You want to use a standard font. If you found this great new font somebody uploaded on the internet and you've downloaded it to your computer and it looks amazing, do not use it. Not for scientific writing, not for laboratory reports. Use something that's very common. Partly this is because you want to use a font that is available on everybody's computer. So you might be on a Windows computer, your professor might be on a Mac computer. Someone else in the class might want a copy and they're using a Linux-based computer. So people are using different operating systems. Some people are using 10-year-old computers. Some are using brand new ones. So you want something that's already everywhere. So you want something common and standard. For places in science where they actually specify the fonts, I've only seen one specified regularly, and that is Times New Roman. So I recommend always use Times New Roman. It's really the safest choice. In terms of the size, what font size should you be using? Unless you're told otherwise, 12 point everywhere. Superscripts, of course, get a little bit smaller, and subscripts get a little bit smaller as well. But except for those exceptions, and most word processors will handle that for you automatically. So if you select it all and set everything to 12, your superscripts and subscripts will still be smaller in most word processors. But with that exception, always use 12 point size. Not 11.5 and not 12.5, not 11, not 13, 12. Always 12, only 12. There is one other exception that in science is generally accepted, and that is in a figure or table, if using 12-point fonts would cause it to be larger than one page. But you can make it a little bit smaller, so like a 10-point font, and it fits on one page, then it's acceptable. So that's basically the only widely accepted exception, is that it is for the purpose of having a figure or table fit on one page. So otherwise, even figures and tables, 12-point fonts. What about the line spacing? Different people have very different ideas about what the line spacing should be, so there's a lot more variability in this. Check with your professor, check with the instructions. For laboratory reports, I suspect it's most common that people like a 1.5 line spacing, but this will vary a lot. Some professors probably like single-spaced, and some probably like double-spaced. People who are just going to read it and maybe make a few comments tend to like single spacing. People who make lots of comments on the paper and in between the lines tend to like double spacing because it gives them space to write their comments. And people who sometimes do one way and sometimes do the other tend to like 1.5 because it's sort of in between. So if you're not told, I recommend you try 1.5 line spacing. Now, which things should be centered and which things shouldn't be? Well, your main title, probably on a title page, a physically separate piece of paper, should probably have your name in the upper right, the date the experiment or research was conducted, if you had partners involved in the research, the names of your partners, if it was for a class, the name of the class, if that class meets, if there's more than one section, so like there's the Tuesday period 3 group and there's the Wednesday period 4 group, it should probably specify which section you're in. That kind of information, probably upper right, which is a little bit weird. We usually don't put things on the right, but for a title page, that would be appropriate. Then the title itself, the title of your report, centered. And then you'd go to the more standard left justification for almost everything, except for the headings. Usually headings get centered. So materials and methods would be centered. Results would be centered. Discussion would be centered. And depending on the style, probably the headings would also be in bold, maybe the title of the report as well. Basically everything else should be left justified. So when you're not sure, go for left justification, because usually that's the safest. And I have here written on the slide, for example, table titles. Notice that just because it's a title doesn't mean it gets centered. If it's a table title or a figure title, it still should be up against the left margin. So it should say table, space, 1, and then either a period or a colon, depending on the style that's being used, a space, and then the actual title. So it's up against the left, not centered. What about more simple details like paragraphs? I've mentioned this before. Paragraphs are left justified. As a general rule in English, you should use left justification, not full. Jagged right edge, a straight left edge, except for the first line, where the first line is indented by 1.27 centimeters. And as I also mentioned in another video, usually you just hit the tab key once and your word processor automatically indents it by 1.27. If, however, your tab marks have been messed up a little bit, then you might have to fix them or use paragraph formatting to get your paragraphs indented properly. What about blank lines between paragraphs? No. No blank lines between paragraphs. Generally, once you start the introduction, there would probably be no extra blank lines in the report. No blank lines at all. Some people like to put one extra blank line at the end of a section, so you finish the introduction, put in an extra blank line, and then centered materials and methods. But you would not have an extra blank line after the materials and methods. Whatever your line spacing is, if you're using double spacing, for example, or 1.5 line spacing, that would be going on. But you would not add extra blank lines, and certainly not between paragraphs. Okay, what about headings? I've mentioned this already. Follow the instructions. So if you're taking the AES class, you've almost certainly been given or will be given a handout with guidelines. Whatever the guidelines say, always do what you're instructed to do for these types of things. If you want to make sure that you're not going to upset the person receiving your report and you do not have instructions, ask. Ask them how they like it. Bring a sample to show them. And say, do you like it censored? Do you like it in bold? Just ask. Find out what would be best. If you don't want to ask or you can't ask and you're preparing something and you do not have the instructions or there are no instructions, then I would say a few basic things. First, your introduction, do not even write the word introduction. Everybody knows the first thing is the introduction. So there's no reason to put the word there at all. That's pretty standard in English writing, including scientific writing. Another thing, center your headings, so materials and methods, results, discussion, references. Center those things and put them in bold, but leave them in the same font and the same font size as the rest of your text. So probably Times New Roman 12 point, but centered in bold. So, tables and figures. Where should you use them? Why should you use them? I've talked a little bit about this in other videos, but basically a table is used to present information that can be most easily understood and arranged in columns and rows. So if you're thinking that, oh, you'd like to show somebody a spreadsheet of something, that would be a case where you would use a table. A figure is, the term figure in scientific writing basically refers to almost any other thing that's visual, that's not merely paragraphs. So for example, if you drew a diagram, so you used lines and squares and triangles and labels to show how things were set up for something, that would be a diagram. You could label it diagram, but we normally would call it a figure. Maybe you took a photograph of your experimental setup so that you could include it in a laboratory report. You might label that photograph, but more likely in scientific writing, we would just label that as a figure. The most common figures, of course, are graphs. So where you plot your data. You have an x-axis, you probably have a y-axis, and you plot your data. You might have a bar chart, you might have a pie chart. It depends on what research, what kind of an experiment you're doing. But basically, we often like to supplement our writing in science with something more visual or more orderly and organized, like a table or a figure. Just remember that your tables and figures supplement. They add to your paragraphs. All the key findings need to be in the paragraphs. So, when you're doing your writing, think about what you wrote. Is it clear enough in paragraph form? If something more would help your reader, like a figure or maybe a table, then try and create a useful figure or table to help your reader. So let's say that you're looking at your description in your materials and methods section, and you're thinking, boy, you know, if somebody wanted to do a replication, they wanted to do this research too, and all they have is my materials and methods section, if you think your paragraphs might not be clear enough, how about a diagram? Why not create a diagram for your reader that shows graphically a schematic diagram of the experimental setup, so that if they then go and do the research, they can set it up the same way, or at least understand how you set up your research. So think about adding diagrams, and as I said, we would normally just label it as a figure. So for example, figure 1, experimental setup. But a diagram can help. One other thing I should mention about diagrams, if I haven't already mentioned it, is that rather than trying to create a diagram in a word processor, you should probably create your diagrams in other software, most likely presentation software. So if you're using Microsoft products, probably in PowerPoint. If you're using Apple's software, probably you'd use Keynote. If you're using the free software that can be downloaded from the internet, known as OpenOffice, there's a program in there called Impress that also does the same types of things. So for example, right now, I'm using one of these programs for this presentation. It's bringing out the bullet points and so on. But these pieces of software are designed with visual graphics in mind. Consequently, it's usually easier to learn one of these programs and create your diagram there, export it as a JPEG image, and then import that JPEG into your word processor. That is usually easier than using the features of the word processor to create essentially the same diagram. So even if you're thinking, oh, I know how to use my word processor, but I do not know that other software, you'll probably save yourself time by learning the other software, because word processors were not really designed for graphics. That was sort of an afterthought, and so it usually doesn't go smoothly. It causes lots of problems. So my recommendation is build your diagrams in other software, export them as a JPEG, then import them into your word processor. Now remember, the goal is to help your reader. So the question you should always be asking yourself is, if I provide my reader with a table, will it help them? If it will just confuse them, or if it will just give them more data that they probably do not want to see, do not create the table. But if the table will help them, then create a table. And same thing for figures. Would a graph help your reader? If it would help your reader, if they would like to see this data graphed, then provide them with a graph called a figure. So do provide tables and figures if it helps your reader, but do not use too many. A few is usually helpful. 1, 2, maybe 3 in a laboratory report can be very, very helpful, very, very good, very useful. But when you start getting into more than that, unless it's a very, very involved project, and it wouldn't be a couple-page laboratory report, we're talking 5, 10, 20-page reports or longer, then when you start having too many, it actually confuses the reader. Because the reader needs to read, not merely look. They need to read. So they need to read the paragraphs and understand the key results, and then look at the figures or the tables for extra supplementary, a little more expansive information. So don't go overboard. Don't say, oh, I'll skip this paragraph and I'll do it as a graph instead. No, write the paragraph and say, see figure 4, and then give them as supplementary material that figure 4, that graph. So do not use the graphs and the tables instead of presenting your key results in paragraph form. Use it to add to give a little bit more in a clearer way. Also, be sure you pick whether you should be doing a graph, a figure, or a table based on what the reader would want. So it's usually easier to create a table, and it's more difficult to create a graph. But if the goal here when you're writing is to write so that it's easy for your reader. So if a table would work, but a figure would be better, do the figure, not the table. But don't do both. Don't put the same data in a table and in a figure. Pick the one that's better, do that one. One other thing, I've mentioned this elsewhere, every table and every figure must be mentioned at least once somewhere in the text. So when you're proofreading, you need to check for this. If you have a figure 3, make sure that somewhere in your writing it says, see figure 3, or it says, figure 3 presents the data on. It somehow, somewhere mentions that figure. Every figure, every table must be mentioned at least once, somewhere in the paragraphs. And it can be in parentheses. That's fine. You can give your key results in sentence form in a paragraph, and at the end of the last sentence in parentheses, just write, see figure 1. That's perfectly fine. But it needs to be mentioned in a paragraph somewhere, because that's the point at which the typical reader will look at the table or the figure. Most readers will be reading the words, and they only go to look at the tables or figures when they see the notation, when they see it mentioned. So if they don't see it mentioned, they literally will turn the page and never look at the figure or the table. So you always have to mention it. Okay, I've mentioned this before as well, a very important one. You need to write logically. And when you're proofreading, you need to really check carefully to ensure that your writing, in fact, is logical. Now, many people might not realize this, but in spoken languages, when you're speaking, people tend not to be very precise. They'll often use an incorrect word, they'll sometimes leave out information, and they assume that, the listener will understand. And in fact, usually, the listener does understand. So, although I haven't checked yet, I will be listening to these videos later, and I will probably hear lots of mistakes and be very embarrassed. But in spoken, we make lots of mistakes and don't even notice them. But in writing, people notice. People notice quickly. And of course, scientific writing is supposed to be precise and accurate. So you need to be very, very careful when you're writing in any language, be it English or Japanese, it doesn't matter. You have to be extra careful to make sure you're using the correct words, that you are writing things logically, and of course that you're using proper forms and punctuation and so on. So when you are doing your proofreading, double check this, triple check this. Make sure everything is clear. Make sure the logic is correct. Make sure that everything is really how you intended it to be. So for example, oftentimes people will use the word therefore. But therefore, in almost all cases, is a cause and effect related word. So this happened, therefore this other thing occurred. So you're expecting cause and effect when we hear the word therefore in English. So if you have the word therefore somewhere in your writing, during your proofreading, you should stop right there in the middle of a sentence. You are proofreading along and you come to the word therefore. You should stop and look at what's right before the word. Is that in fact a cause? If it is, now look at what comes just after the word therefore. Is that the effect from that cause? If so, that's fine. Continue your proofreading. If not, stop and fix it. So literally look at every word and think about the logic. Another one that comes up a lot in terms of logic and scientific writing is the word subsequently. Oftentimes you'll be describing your procedures. So you did one thing and then you did something else. And you might use the word subsequently for that to indicate the time sequence. So when you're proofreading and you come to the word subsequently, check and see, is the thing right before it the earlier event, and is the thing right after it the later event? If not, you need to fix it. And again, make sure you're using the correct words. So subsequently and consequently sounds pretty similar, but they're different words with different meanings. So make sure you're using the correct words and that you're using them in the correct way. Always check the logic of what you write. Now, proofreading, I keep mentioning proofreading because it's really, really critical. What is proofreading? Proofreading is not reading your report and hoping you notice errors and can fix them. That is not proofreading. That's reading your report and hoping that you will notice errors and fix them. Proofreading refers to very carefully going over every aspect of your writing. Everything. Making sure everything is clear, making sure everything is correct. And when I mean everything, I don't mean just the words. I really mean everything. If you merely read through what you wrote and hope to notice errors and fix it, you are not proofreading, and I can pretty much guarantee you, you will have lots of errors. Now, let me just quickly mention here something that I hadn't mentioned before. In these 2 bullet points, you might have seen something a little bit different than I didn't do in most of the other videos. I have a few words here in italics. So the very first bullet, it says proofreading, refers to carefully going over. And in the second bullet and last line, you're writing will have many problems. Why do I have italics here? Well, in modern English writing, both scientific and regular, but in modern English writing, if you want to add some emphasis, what you do is you put the word or the term in italics. So you do not use bold. Do not use bold. You do not use all capital letters. I know some people do that on the web. It's actually considered rude. It's taken as if the person is shouting. So you want to add some emphasis, but you do not want to be using all capital letters. You should not be using bold. What you should use is italics, just a little note for when you're writing and want to emphasize something, as opposed to de-emphasizing when you put things in parentheses. So back to proofreading, you have to check everything. Did you italicize the correct words or not? Everything needs to be checked. Absolutely everything. That includes the formatting. So are the fonts correct? Are the sizes correct? Are the margins correct? Is the line spacing correct? Is the page size correct? All of these things have to be checked. Is your word choice correct? Did you pick the correct words? You wrote subsequently, not consequently, when you meant subsequently. Did you write the correct words? Are they the ones you want to be using? Do they convey the meaning as precisely and accurately as possible for the language you're writing in? And of course, the form of the words. If they're nouns and it's a language that has plural and singular forms, make sure you're using the right one. For verbs, past tense, future, future continuous, past perfect, there's lots of tenses. Make sure you're using the correct ones. So again, proofreading is not reading and hoping to notice a problem. You look at every single word and every phrase and every sentence and all the punctuation within the sentence and the spaces between words and between things. So there should only be one space between words. There should be a space after every comma, after every semicolon. There should be no spaces in front of a comma or a semicolon or a colon. You check everything. So proofreading will take a long time, but it's really, really important because if you don't do this, when people read your work, they will notice lots of little errors, lots of little problems, and it won't necessarily confuse the reader. You still might successfully communicate, but the impression you create in the reader is that you're not careful. You do not check your work. And that means that they're going to be having a somewhat negative view of you. So it's really important to proofread and to proofread carefully. So let me give you a few more tips regarding proofreading. So written language, it's more formal than spoken. It's not just that we notice errors more in written than we do in spoken. That's also true. But written language, in almost all languages, certainly in English, but in almost all languages, written is more formal. So for example, in some of these videos, I've probably used the word don't, or you shouldn't. That NT, the contraction, contractions, you're not supposed to use them in formal English writing. You should never have the word don't, can't, won't, wouldn't, he'll, she'll, any contractions. They should not be in formal English writing, and therefore they should not be in scientific writing either. Why is that? Well, that has to do with formality and informality. So written language is more formal than spoken. So keep this in mind when you're writing and when you're proofreading. So as you're proofreading, did you accidentally or intentionally use any slang? You probably should have no slang in any formal English document. What about sayings? You grew up your whole life. Everybody around you knows the saying. People use it regularly. Doesn't matter. Sayings are informal. You never use sayings in scientific writing. Same thing for informal terms. If you get a lot out of this video, I'll be very happy. If you got a lot, because this is the third time you watched it, got. Not get, interestingly, but got is an informal term. If you learned a lot by watching these videos, so not if you got a lot out of these videos. Spoken language can use got very easily, but written should not. So you need to learn which words are formal and which are informal. Nowadays, it's hard to, oh wait, nowadays, that's an informal term. If you're writing, don't write nowadays. Write something like, in the current era, at the present time, over the past few decades, that sort of thing. But the word nowadays is an informal term, so you're not supposed to use it. So keep in mind, start to learn what words are formal and which ones are informal. And when you're proofreading, check for that too and fix any problems. As I've mentioned many times, but it's a common problem, so I will keep mentioning it, modern scientific English does not let you use I or we to refer to you as the writer, the investigator, the researcher, and similar words like my or you or your or our. These types of words should not be there. So when you proofread, check for those words. Remember, you're looking at every single word, as well as every phrase, as well as every sentence, as well as all the punctuation, as well as all the formatting. Check, and when you see these words, fix it. Readjust the writing to get rid of them. Usually that will be done by using passive voice, and almost always that will work. If for some reason it does not work, then you can do something like saying, the present author decided to do this research because. So instead of saying, I decided to do the research because, the present author, the present researcher, the present investigator. But usually passive voice will work, and usually it's the better choice. Also, of course, as you know in English, many nouns have a singular form and a different plural form. When you're proofreading, if you come to a noun, ask yourself, does this have a singular and a plural form? If it does, which are you supposed to be using in the situation that you're looking at? Make sure it's correct. Look at every word, check every single word. But words interact. Check for subject-verb agreement. The book is. The books are. So you have to pay attention to, is your subject singular or plural when you're matching with a verb that has a different singular and plural form. So you need to check these things when you're proofreading. You need to check them very carefully. Obviously, when you're dealing with verbs, you also need to ensure that you're using the correct tense. Don't use future if you meant past. So there's lots of different verb forms, lots of different tenses. Make sure you're using a correct tense. I say a correct tense because sometimes there's more than one that might work, that might be correct. Maybe you could use past or past perfect in a particular place. So pick one that is definitely correct. And of course, among those that are correct, pick the one that conveys the meaning you're trying to convey to your reader. So let me pretty much close up here by pointing out that you should always check to ensure that you are using the correct words and that you are spelling them correctly. Now, I know some of you are saying, well, after I finish writing, I always run a spell checker. And some of the other people who are watching this video are saying, my word processor puts a squiggly red line under any spelling errors, so I never have spelling errors because I see the squiggly line, I fix it. Well, if we were to put this slide through a spell checker, a typical English spell checker, there would be no errors. Yet, there are 9 spelling errors in this last bullet point. Why? Because they're not really spelling errors, they're word choice errors. So if you didn't notice 9 errors in this line, you're not proofreading carefully. So remember, you cannot trust a spell checker to fix the problems in your report. Do use spell checkers, but you need to check every word yourself, make sure it's spelled correctly, make sure it's the right word, make sure it's in the right form, make sure it's interacting with the other words in the sentence correctly, make sure the sentence is formed properly, the punctuation is correct, make sure that the paragraph is on one topic, it has a topic sentence, it has support, it has a conclusion. Make sure that everything is formatted. That your paper is set for A4 size. You have 2.54 centimeter margins. Your line spacing is whatever it is you've decided it will be or told it should be, like 1.5 line spacing. Make sure your fonts are consistent, probably only one font throughout the document. The font size is consistent. Check everything. Remember, proofreading is a skill and it's an important task. Anything you do in writing should be proofread. I've been on committees for hiring people at various universities, and I have received and been looking at applicants, their cover letters and their resumes, and I've seen errors. What's the first thought that goes through my head when I see formatting problems or a verb in the wrong tense? My first thought is usually, they're not careful. They did not even bother to proofread. I then take their resume and throw it in the garbage because I'm not going to bother interviewing them and I certainly don't want to hire them. When you don't proofread, you create an impression in your reader. And the last thing you want to do, for example, in a laboratory report, is have your professor pick it up and even before they start reading think, this student is not being careful, this student is not checking things, this student is not doing things right. You don't want to start your reader thinking ill of you. So proofread carefully and write well. Hope these videos are helping you out. Remember, some of these things like proofreading is a skill. It takes practice. Stick with it.